Okay, good afternoon. Welcome to the second to last session here at CyCON US. Glad you guys could make it. In this session, we're going to talk about artificial intelligence and cybersecurity, and we're particularly going to talk about how do we tackle this challenge of what's known as adversarial learning. As you can see here, our distinguished panel has reduced a little bit. We did have some weather issues, so rather than a panel of four, there'll be a panel of one and myself. So we're going to change the format a little bit. We're going to start with a little bit of an overview from General Evely, who I'll introduce here in a sec, on the newest, I guess it is the newest task force in the Army Artificial Intelligence Task Force. And then we'll try to transition over to sort of some questions around cybersecurity, and we'll have a little fireside chat / Q&A on that, and then we'll open the floor for questions. So let's officially get started. So machine learning capabilities have recently, and when I say recently, probably over the last 5-6 years, have been shown to really offer some astounding ability to automatically analyze and classify large amounts of data in complex scenarios. That's including cybersecurity, in computer vision, in text, in natural language processing, and various fields. And in many cases, it really surpasses our own human capabilities to perform those types of tasks relatively quickly. However, some of these same algorithms that drive what we call machine learning, which is a subset of artificial intelligence, they're really susceptible to what we call adversarial learning attacks. And typically, there's three main types of these adversarial learning attacks. We have data poisoning. And this is a type of attack where the malicious actor will inject basically maliciously labeled data points into our training data, right? So in machine learning, we're trying to learn from data, and in doing so, that data is extremely important. And so if the data that's used to build our models that are used to perform some sort of classification task or recognize some sort of image or detect a cyber threat, if the data that's used to build that algorithm is then changed by an adversary, well, that's not a good thing, right? Because then we may make the wrong classification and hence wrong decision. So we have a data poisoning attack. And really what that is in machine learning, we're trying to come up with a mapping between inputs to outputs. And in doing that sort of poisoning attack, we sort of destroy that mapping, or we don't create the correct mapping. The second type is what we call an invasion attack. And this is where we are sort of perturbing our training set, or even our labels. So for example, if we built if we had an algorithm that was used to classify whether or not an image was a cat or not, okay, well, if all of a sudden the adversary came in and said, okay, we learned that given these images, these are all cats, but now they came in and changed the labels and said, nope, these are dogs, these are elephants, these are something else. Well, that's a problem too. And finally, we have what are known as inference attacks, and these are really repeatedly test the trained algorithm with these different edge case inputs in order to reveal what are known as previously hidden decision boundaries. So in machine learning, in a multi-dimensional space, we're coming up with these decision spaces for which we can then classify. So that could be, as simple as a binary classification, this is a threat or not, or if it's a sort of a multi-class situation, like a particular type of malware, for example. And so changing those decision boundaries would have a major effect on our ability to correctly and accurately classify. So these are just a few of some of the adversarial learning challenges, among many others that are coming up every day. And some of the greatest ways to protect against these learning attacks are the way in which we train our algorithms. So for example, one scheme is to get rid of a lot of our outliers and allow us to actually have a little bit weaker accuracy on our training data set, but that allows us to have more robust classifiers for those out of sample observations that we haven't seen. So that's just one type of way to combat this. So in this talk, we're going to talk about, how do we combat this, right? Because artificial intelligence and its impact on cyber is, yes, it's on our network. So it's on the DODIN, it's on our computers. But if we're going to go big with artificial intelligence across the Army, from our weapon systems to our vehicles, whether that be ground vehicles or air vehicles. And well, those are all going to be able to make autonomous decisions based off some sort of sensor. And those sensors at the tactical edge are at risk, in particular, for these types of threats. So without further ado, I would like to introduce our speaker, no longer just our panel member, Brigadier General Matthew Eveley. He assumed responsibilities as the director of the newly formed Army Artificial Intelligence Task Force, which is now under Army Futures Command. This is literally within the last few months. And in his role, he's really helping leverage and integrate our current and future operational artificial intelligence efforts, as well as the various research and development efforts Army-wide, whether that be at Army Research Lab or NetCom or Army Cyber or across the enterprise. We have folks in all places and spaces working on this, and now it's, well, how do we operationalize this? How do we do this in quick sprints that enable us to actually to build this capability? So, General Easley.
Great. So good afternoon. Pleasure to be here again. General Matt Easley. I'm the Director of Army Artificial Intelligence. So it's a new office that we stood up. Again, Chief of Staff of the Army kind of authorized us in mid-October. I was brought on board in September. So without any further ado, I'll talk for a while. I mean, if there's any huge questions, and if you're got a pertinent question you can't on the tip of your tongue, please feel free to get up and talk. We make this more of a discussion than general, just a straight lecture. And then we'll obviously have Q&A at the end. So, found my slides. Thank you. So, as we all know, the commercial sector is driving huge numbers of areas in artificial intelligence. You'll hear all the news reports almost daily about different innovations of self-driving cars, of different workshops, different efforts being stood up, what all different countries are doing around the world. One of the big examples I like to highlight is MIT just started a new school. So they have about $1 billion investment setting up their new computer science school to focus on artificial intelligence. But you can look at almost every other major research institution in the United States setting up large laboratories, my alma mater's hiring 25 professors just at the University of Colorado just to kind of meet the demand of what this is going to do to change our society. Again, there's huge wide applications, not just in the civilian sector, but also in the military sector, from autonomous vehicles, robotics, manufacturing, infrastructure, finance, mobile devices. It goes on and on. I at least thought I was talking about the Army staff. I was at a talk last week, and one of the secretariats got up and said, "Oh, you didn't talk about installation command." And I said, "Oh, no, I didn't talk about installation command because I hadn't thought about artificial intelligence for Army installations." But he jumped on me and said, "Well, we have a huge need because they want to increase their security posture, use AI to kind of reduce the number of security guards we need at Army installations, do a better job of water management, power management, all the kind of smart city initiatives that our rest of the world is doing. How can we bring those to the Army?" And then I just realized I had one more customer to my huge and growing list. I think the CEO of Google has changed their company's philosophy over the last month. It was either in September or October. They announced that they're moving themselves from a mobile-first company to an AI-first company. And it's not just Google, it's many other companies you can think of, all the social media companies. How do they get better content directed to a person is all based upon making their algorithm smarter, a little bit more customized for the users. And we can think, and then we'll get to it at the end, how do we do that same level of customization in cybersecurity for all our systems? There's a big challenge that I have for my boss, and I think many of you may have the same challenge, trying to precisely define what's within the realm of artificial intelligence and what's not. A lot of things that we consider just routine now, from our search engines to our mapping applications. 20 years ago, 30 years ago, we said, well, this is a great use of AI. And now they're so commonplace and they work so well that we don't even think of them as AI. I know when I was getting my PhD, we didn't even use the term AI. When I graduated, I didn't, because we're kind of in one of the AI winters and it was kind of a bad word. And typically what happens, and if you've been in the field for a while, you'll see we change the names when we have something successful, we changed the name to computer vision, to speech recognition, to deep learning, to machine learning, where we actually, have these good wins. For us in the military, it's actually a little hard for us to even find what we're spending the money on, and that's one of my first charters, because we for science and technology funding at the lower levels, when it's more applied in actual research labs, if it's an Army research lab, or if we're sponsoring academic research, or small startup companies, it's easy to identify the money. But once it gets rolled into a larger program of record, and it's now kind of a part of a larger platform, be it an airplane or a ship or a human resource system, it's a little bit more difficult to define and say which part of this is artificial intelligence. Kind of one of the seminal papers I read back in the 90s was called "Where's the AI?" And if you look from just a system, how much of that system is really the algorithm and the data part, and how much of the rest of the system has to be the infrastructure that supports that algorithm system, it's a big ratio. Typically, if you look at source lines of code, the algorithm part can be very tiny. And you see some of these startups, and their core piece of their algorithm is just a few lines. I mean, tens of lines for some of these companies. Again, it's a high-level language, so it can be doing a lot in 10 lines. But all the infrastructure that they have to get, all the databases, all the user interfaces, all the other pieces to get that data into the algorithm and get it out, and then get it to a user, be it a mobile device or an entity in the cloud, is exceedingly difficult. And it takes a lot of system engineering to be able to do that. And you'll see that as we go through my talk on that. So again, for a lot of us, not just the US, that's why we're here giving this talk on AI and adversarial AI. A lot of other companies you've probably read of, countries are spending money on artificial intelligence as well. Both European countries, Asian countries, every major country has large sums being applied in this domain. So for the NDAA 2018 has a long laundry list of AI priorities for the federal government and for our national military. Everything from being able to apply capabilities faster, to have better talent management, to investing in our future. And then there's actually some explicit verbs on using artificial intelligence in the National Defense Strategy. As part of that, the DoD CIO, Mr. Dana Deasy, came in, was recently appointed, and announced the stand-up of the Joint Artificial Intelligence Center here in the National Capital Region. And again, they're starting a number of national mission initiatives for the Department of Defense, and with that, we'll have a number of kind of supporting agencies across the DoD. They have developed a Department of Defense strategy for AI, and my organization is working its piece as an annex to that strategy. So one of our big issues, and I've been tasked by a number of the more senior generals in the Army, is how we're going to operationalize artificial intelligence. How are we going to get this to the user on the battlefield? If you think a lot of what our civilian society is using with artificial intelligence now, it's mostly in a non-adversarial setting. So if you think of all, be it whatever your social media feed, be it whatever help piece you're using, be it Yelp or Google, you are not telling it falsehoods, right? When you go review a restaurant and say, I like coffee, or I like going and see country western shows, or any of these types of things you're liking, you're training that algorithm to help you and to teach you what you like. And you're purposely not trying to spoof it. But in an adversarial setting, that happens. So a good example, and it's not just artificial intelligence, is if you harken back to some of the World War II, so as the Allies were going through France, trying to get into Germany, the Germans would change all the road signs. And why would they change the road signs? They were trying to spoof spoof the US, just going to the wrong cities. So they were trying to purposely misdirect us on our forward advance, so we thought we were going to city A, but in reality we were going to city B because they were using good spoofing techniques. So you can say the same thing, well, what's going to happen when people start getting just disgruntled teenagers or pissed off employees, or somebody start mad at a lot of the self-driving cars around town, and they start changing road signs or changing those type, and it's not that hard to trick some of our artificial intelligence right now. So we're gonna have the same kind of issues as we move on to the battlefield. You can think of the battlefield already, what's happening in Syria now, where there are lots of swarms of UAVs attacking, surveying allied forces there. You can imagine that's only gonna get worse as we go forward. I mean, most of these small UAVs are not very expensive to purchase, put cameras on them, put small sets of munitions on them. How are we gonna maintain situational awareness of all these pieces as we get more and more soldiers on the battlefield? You've probably seen pictures of a lot of our soldiers with doing unmanned and manned systems. That's one of our big initiatives in the Army. How are we gonna connect those devices and all those endpoints into our system? If you think of some of the self-driving cars that we're deploying right now, be it from Walmart or Google or NVIDIA or whichever company you want to look at, think of how connected that car has to be to our city infrastructure as it moves around. So from the data it's using for maps, for its GPS kind of inputs, all those pieces in a relatively benign environment. I mean, people are not trying to spoof the GPS on it to tell it the wrong coordinates. So as we move into this new 21st century battlefield, when we have unmanned systems, and we're trying to make some of these robotic agents a little smarter out there, how are we gonna protect those, both not just from spoofing, but also from cyber attack? But the potential is amazing of what we can do. One of the examples I like to talk about is what Google does to the traffic in Los Angeles. Everyone talks about how bad the traffic is in the DC area, and I can tell you it is not anything like it is in Los Angeles. So what happens is we all try to get off the roads and get onto city streets because most of the roads are parking lots. And I had my secret, a couple months ago I was driving my kids to school. Again, I knew the freeway was going to be packed. I knew even the main kind of service street was going to be packed too, so I was just going to start using the back roads. And back roads are really good, and go through, got me there really fast. Well, what do you think when I kept doing that? I taught Google the back roads, right? And then one morning, I started getting onto my little secret back road, and there were 100 cars lined up. All just from, I mean, this is just a quiet residential street, but everything you saw was just, it became a parking lot, because what happened? Google learned it because I taught it, or my neighbors taught it, and that then became the new thoroughfare. So you can imagine we can do the same thing as with our military formations and say, well, look, how do we share this knowledge among all our soldiers on the battlefield about what is the new fastest route, or how do we get our soldiers to the right place, or even how we move munitions or get the firepower to where we need to, and how do we kind of harness that level of swarm behavior that Google's already kind of creating in or other companies creating in our navigation devices for the battlefield. So there's, as you can imagine, there's huge expectations. I went to the GPU conference a few weeks ago here that NVIDIA sponsored, talked all about the Internet of Things, especially on how graphical processing units are gonna help make AI smarter and better. But as Nate talked about, AI is not all that easy. A lot of the cases a lot of our big wins that we've been talking about, I mean, like one of the big wins we all talk about is how Alpha is now being able to beat all the grandmasters in Go. But it did that with a huge amount of data. That algorithm probably played more, I mean, orders of magnitude more Go games than all human beings have ever in human history, because it could just play that many games. And given that many games, it's going to learn enough that, yeah, it's going to be able to beat some of the Go masters. Same thing with the Atari game. When I first read about the ability of effectively an untrained system, just having the input and output of a joystick and the output of success on the game, no other level of knowledge at all, being able to play basic 80s level games. I mean, even from, I mean, again, all they gave it was input-out control of input of the control, output of how well it did the game, and just full pixelation of the graphic. So no knowledge at all, being able to play expert level games. But in those circumstances, again, it was perfect knowledge. It knew exactly what the game was, and knew if it won or lost, and it effectively had as much knowledge as it needed to do because it could create its own training data on the fly. In real AI problems, that's not the case. We have much more dirty pictures. The training data is difficult to create. It takes a lot of time and effort actually to say, okay, this is what this system means. And that's one of the big things I'm trying to tell people as we bring in artificial intelligence to the military, is which cases is working well and which cases is not working well. In the standpoint of where you have good data, you have a lot of it, and it's relatively clean, you can learn a lot from the data. A good example I like to bring up is for radiologists and the x-rays. Typically, they can go in and identify this is this type of cancer, or this is this type of fracture. They can look at the x-ray, and no one's trying to spoof that data. But once the data becomes more malleable, a lot of the assumptions for the algorithms no longer hold true. For the traditional algorithms to work well, you need the input to be what's called stationary. So it's a normal control system where we have our input set and an output set, and then we assume that the data coming in has some predictability to it. Once that condition of stationarity no longer holds, you got to look at and update your model to reflect the new data. And this problem of having the input and output not reflect the model is not novel to artificial intelligence. I was listening to a good article a few weeks ago about a coroner in Southwest United States, and they were trying to tell how old a corpse was from the bones. So they had just mummified bones, and they were looking at the bones and trying to figure out, just kind of reverse engineering, how old was this person when they died. And again, a lot of data, so they did a lot of studies from cadavers and took dead people's bones, look at the bones. They died at age 50, they died at age 70, they died at age 40, and from that they inferred a model and said, okay, if you have these type of hairlines, you have this type of, or we can come up with the age of the deceased person. Well, one of the problems is most of that data was collected in the 1950s in the United States in small kind of academic towns in the Midwest, because that's just where the research was funded. So for that population, the data works really well. The model fits the people. But when you start looking at different populations of people, so maybe Hispanic descent or other ethnic groups in the United States, the model doesn't work very well because the data didn't reflect the model. And we're going to have that same type of problem as we go forward with AI, especially adversarial AI in the future. We'll have to look at how we train our systems. If we're training our systems to work well in one desert environment or one type of foliage, how well is that same type system going to be able to identify threats and targets in another type of system? And how fast can we get that data updated when we move to that new environment, and how do we get that data pushed out to enterprise? Back to my talks here. For the 4 slides, again, I already talked about the clean data. It's got to be integrated in your system, tagged, marked well. We got to have good use cases. A lot of the times when a lot of potential customers of mine come up and say, well, I think AI is really going to help me. And I talk to them about their problem. And I say, well, no, I don't think you really have an AI problem. You really have a data problem. Your data's not clean. You're not using your data properly, and you got to be able to find ways to clean that first before you can ever think about AI being able to help you. We need talented people to do this. Just like for a lot of the network security, you have people with expertise in those various aspects. I know in the last talk they talked about how long it took to actually kind of train up the cyber community to understand that that was a big need for the community, and it took years. That's the same type of thing is going to have to happen in the enterprise level for not just the military, but also all the large corporations. Is how do we get that cadre of talented people who understand where and how to use the technology. And then finally, I mean, the technology itself. Deep learning works well on certain types of problems, but it doesn't work on all problems. And trying to find which ones work to which ones is a key aspect of this. For us in the DoD, a lot of our problems are, as you can imagine, our data is siloed and static. So we have lots and lots of databases. I think the Army is running more than 1,000 databases. Databases aren't necessarily talking to each other as well as they should. So we're looking at ways we can move our data into cloud-based systems to make it a little bit more open and being able to stream data into it and out to it. Before you can make these algorithms work, there's a lot of effort to clean the data up. And a lot of people just kind of overlook that fact and said, look, most of your work is actually going to be cleaning your data, and you got to account for that in your budget. And then finally, as I think I already mentioned, once that data is available, there may be better ways to use that data via traditional statistical analysis, automation techniques, other than just trying to say AI is the big new thing to use it. So as I said, there's already lots of definitions of AI, multiple different subfields, symbolic logic, statistical methods, search and optimization techniques, natural language processing, et cetera. I spent a lot of time last month at AUSA talking to vendors about what they thought AI was and what kind of some of their AI products that they were bringing to the offer. And a lot of them also, well, AI is just data and algorithm, which I have up here. And what I've been talking to so far, and what Nate kind of talked to us at the center, is this kind of input-output modeling between a set of inputs and outputs. And we take more data in, we update our algorithm, we update our coefficients on our model, and we learn that, and we kind of iterate that. When I was a grad student, when I worked with a lot of research labs, I mean, that's exactly what they're doing, and they do a great job of it. But that's not enough to move AI to the enterprise. And a lot of my work now is trying to figure out how do we actually get this up into the enterprise level? How do we get the network policies, the information of things policies, all these pieces to get to work together to actually have a working system? If you think about the amount of work involved for a lot of your smart applications on your phone, everyone pulls up their phone and says, oh, this works really well, and I don't care what little app you have. But think of the amount of data that it's collecting on you every day, from your likes, from where you're going, from what you're doing, how that data gets put up into a cloud-based system, how they learn from that cloud, they use little bots in the cloud to learn that up there, and then they push that data back down to your mobile platform. There's a reason why many of these devices are asking you how well they're doing, because they're trying to get this learning cycle built into the application. That whole cycle to kind of bring this Internet of Things and machine learning to the military is going to require a huge new mindset that we're just not ready to jump on today. And I'm asking you, as the kind of cybersecurity specialist out here, what type of things we're going to need to do to actually make that reality. I like to do a comparison contrast between the normal software development cycle of what we do both as in traditional industry, traditional program records, but also in a lot of kind of updating, maintaining and defending our network. So we typically have a code development phase. We develop our prototype. We roll it out. We may test it on some circuit hardware, maybe even representative hardware. We test it out, look for bugs. Then it kind of goes into a system demonstration. We show how it works at a small site, small scale. And then finally, we say, okay, we're going to roll this out to the enterprise. I mean, in the Army, it's a big deal when we do this. When we're rolling out patches, it takes us a long time to actually take a new kind of software update patch, make sure that we like the patch or the the new system, make sure there's no vulnerabilities, and then roll it out to enterprise with the hundreds of thousands of endpoints that we have. And it takes us, a surprising amount of time to do that. And when you do that cycle, typically what we get back is just simple bug reports. Say, well, it's working well or not work, and we get complaints, and people call us, and we go in and fix them. In the artificial intelligence cycle, that's actually a fairly similar model of what you do. We need to develop our algorithms, kind of build our structural model. We train those data either on real data or synthetic data. We then test that data against a training sample, and then we deploy it out, again, either to our agents in the cloud, to our endpoints, or to different parts of Internet of Things. And then again, as I spoke earlier, we use some type of feedback mechanism to update that. But in the world of AI, most of that process can be automated. So for, again, a lot of the smart devices on your phone, that feedback loop's being done automatically with no human involved. So how we're going to be able to do that for our systems in the military is a big challenge, and my organization is hoping to work with people like you to do that. So for kind of my 4 lines of effort, we want to look at transitioning technology early to figure out ways we can show the power of AI to the Department of Defense. We're looking at leveraging early prototypes and finding ways to get those out of the laboratory and into the military's network infrastructure. We're going to advise the Army on AI investments, where they should be spending money. For our programs of record, we want to look at integrating capabilities both into legacy platforms, as well as help design the next generation of systems. So one of the big initiatives we're doing now is looking at preventive maintenance at the Joint Artificial Intelligence Center. So we're looking at how do we develop better diagnostic and prognostic capabilities on some of our helicopter fleet. One thing we want to do is make sure we're not developing different solutions for each platform we have in the military or in the Army. And that's part of the charter of both the Joint Artificial Intelligence Center and my organization. We also want to make sure that when we're developing new platforms, we're wiring those platforms up for those capabilities from the beginning. We're also going to look at other kind of capabilities areas as being part of Army Futures Command. There are 6 priorities that the Army has for its efforts, and there's 8 cross-functional teams supporting those 6 priorities. So one of our first charters is help integrate AI into those cross-functional teams. But there's, as I kind of mentioned with the side note on Army installations, there's lots of capabilities across the Army that needs these capabilities, from how do we recruit and retain better soldiers, to doing talent management, to even doing medical systems. For AI policy, we need to find replicatable processes. How do we not have everyone develop their own system? We want to be able to move these processes from the lab, do it repeatedly and quickly, and get them up into the enterprise. We want to advise our program of records on how they should use AI, as well as coordinate with a number of agencies across the Army, especially the Chief Information Officer, to make sure that the rest of the Army's IT structure supports artificial intelligence, from developing software to putting new software on the network, as well as how we're going to govern all this new code. There's a big push for common foundations for artificial intelligence. Again, we need an architecture that supports AI both at the tactical edge as well as in the cloud. We need to make sure that we're building kind of our cloud structure, both at the Army level and at the DoD level, to make sure we have the computing power we need. We need help, as I said earlier, on data protection, how we're going to use security, access management, encryption, to protect the data that all these algorithms are so critically need, as well as kind of connectivity from how we're going to go make these work at the enterprise all the way out to our tactical edge. Finally, we want to make sure we can support a diverse solution of vendors, kind of have a vendor-neutral solutions, but have specific models for specific platforms. So for example, we may have a specific model for a given type of helicopter or a given type of ground vehicle, but more neutral solutions at the higher level. We also need to think hard about how we're going to increase the number of endpoints on our system. One of the statistics I heard is that by 2030, you can already kind of do the math in your head for your own house, how many kind of endpoints you have in your house right now. But they're expecting by 2030 that the average house will have 50 endpoints per person in their house. And I don't think we have thought about how we're going to, if we have that same type of number of endpoints in our Army network, especially in a tactical environment, how are we going to defend that? And then finally, we need to develop an Army-wide AI culture. We need to develop and communicate the Army AI strategy, educate, just like I'm doing here, kind of enterprise on AI, what it is and what it isn't, how it's going to change our organizations, our missions, and how it's going to impact workforce. I know you've probably read the same articles I have done that, they expect by 2030 that, 30% of US jobs will be automatable by intelligent agents. And not only will be automatable, it may do a better job than the person's doing. So how is that going to change our society? How is that going to change our Army? It's something we need to think through in lots of different areas. Again, we're here to collaborate with industry and academia, and we're looking to recruit, mentor, and train the next group of AI architects, engineers, and developers. And I think that kind of ends the formal portion of my talk.
Great.
And
so what I'd like to do is hold your questions till the end. We're going to transition to a little Q&A, focusing a little bit more on cybersecurity applications and implications of AI. So we'll start off with a pretty easy question, sir. What are your general thoughts about just artificial intelligence and cybersecurity?
So I think there's a huge opportunity to use artificial intelligence agents to really simplify some of the jobs of analysts. I know in the Southwest Cyber Agency, we were using it to a little bit there. A lot of, as you can imagine, there's a huge amount of data coming into our networks at all our different centers around the world. And again, it doesn't have to be a DoD agency, it could be any agency. I think for automating some of the easy tasks is probably the best place to do. So looking at some of the simple attacks that should be easy to remove, but some of the harder attacks that we haven't seen before, kind of these day zero attacks, I don't see AI as the solution yet. So.
Right. Yeah, and one of the main challenges of just doing this is the whole big data problem. And not only how the volume that we have, for example, typical analysts on, for example, on the Defense Research and Engineering Network, so the DREN or DREN, they get about 9 petabytes of data a day.
Sure.
So how to, first of all, the data is not labeled, so we don't know what's malicious, what's not, at least at the onset. And so this big data, okay, it's big, but we also have the quality issue that we kind of talked about before. So can you think of, how can we actually get better quality data to actually enable us to do even accurate machine learning?
So, a lot of it is just doing system engineering up front and, coming up with a good taxonomy for what you want to look at and maintain. And I think that's why, I know all our networks are already up and running, so it's difficult to go back in and reverse engineer that. But as we're developing the new systems, it's really kind of developing that taxonomy for your data up front that's going to help us.
Yeah. So we kind of touched on this a little bit, but in addition to your general thoughts, what do you think are some of the strengths and then some of the limitations of artificial intelligence, again, specifically applied to cybersecurity?
Well, some of the, I forgot who said it, but if it takes you less than a second to do, then that's something a machine might be able to do well. So looking at some of the normal attack pieces coming in, I think are good ones. But I said that the holy grail of what people want from AI and cybersecurity is to defend against these day zero attacks. And a lot of that is, again, I was spending some time reading over the last couple of days just on this, is very equivalent to a halting problem in computer science. So Turing created this problem, said, well, what set of inputs comes into your machine? Can I create an algorithm that's going to tell, is my machine going to stop or not stop on this set of individual inputs? The cybersecurity question is a very similar question. Is this set of inputs coming into my network, is it going to cause me problems or not? And a lot of people are looking at that really is that kind of hypothetical problem.
So one of the big limitations, at least for me, that in actually doing this in practice is trying to mitigate the false positive issue. Sure. So it's one thing having accurate machine learning algorithms that allow us to detect and characterize threats. But false positives, for those who don't know, that's basically saying that this particular, let's say, log file this is indicating malicious activity, when in fact, in reality, it's really not. All right. So we're really good at maybe getting accuracy, above 70%, but of that 70% saying that this is indeed a threat, for example, or a particular type of malware, a lot of times we're overclassifying.
Right.
And so if our point is to reduce 9 petabytes of data into a more manageable set for an analyst then to then look at with leadership to say, okay, now make a decision. How do we, or what are your thoughts in general about the false positive issue?
So part of that is I think we need to be able to update our algorithms faster. I know a lot of the analysts have been frustrated that they can't go in and kind of tweak the parameters for themselves. And some of that is just making better and faster tools to go and say, like, well, look, I already did this once, I did it again, and I did it 10 times, and I know all 10 times these were the same false positive ones. And ways to train our intelligent assistant on those is, I think, a big and a doable win. So.
Yeah. You also mentioned before a little bit about, you mentioned automation. And how do we kind of differentiate sort of automation from AI in the context of cybersecurity? Do you think automation is really more realistic, or what are your thoughts?
Yeah, I mean, as you probably heard from my talk, I'm a little on the fence of like, where is this stop being automation? When does it start being artificial intelligence? So I think for this, it depends a lot on where we want to kind of draw that line. A lot of people are drawing that line and say, well, is it doing near human level kind of analysis? And in cybersecurity, that's tough to do, because if you look at a lot of the breaches, it takes us months sometimes to find these breaches. So I think that's probably where kind of automation goes in. How do we kind of go through this backlog of data, and when we say, okay, we had a breach, and then we start digging and digging and digging in this data, that's where I think automation is going to help the most.
So in other applications of machine learning, particularly in image recognition problems, or we're trying, whether it be images, still images, or videos, there's techniques such as using simulation, for example, to actually generate realistic scenarios that now allows us to create training data to then train and build our models. It's a little bit different in cyber, right? We don't have videos of attacks. So that, again, leads to this problem of, well, how do we get the training data to actually build these algorithms? So
Sure.
Do you have any thoughts about some of the techniques we can use to sort of train up our cyber warriors out there to actually...
Well, sure. I mean, I think that's why, all our test ranges are so important and so critical, that we can go into a sandbox type of environment and then start generating data. And we'll use it a lot of our cyber exercises where we'll have a blue team there, a black team there, a red team, white team, all being able to work in this kind of competitive environment, and then use that as a way of creating data. And again, you got real people there doing new and novel attack vectors, and again, trying to use that data and learn from that data. I think, and again, then either to automate it or to apply it to an artificial intelligence agent is going to pay big dividends for us.
Yeah. So this talk partly is about adversarial learning, right? And so making sure that our algorithms and our machine learning algorithms in particular that are allowing us to do AI are robust enough to actually make classification decisions. So, and that could be on our network. So, for example, in the DoD information network, we care about the network and we also care about the computer, right? A lot of times, if you're semantic, you really that's a software that's on a computer and that's protecting the computer from viruses and things like that. Whereas if you're Verizon, for example, you care about bad stuff getting on your network, so they have cybersecurity focusing on their network. Whereas in the DoD information network, we care a little bit more about both and doing so at scale and in real time. And so my question is, how do we, and this is more of a thought question, but how do we actually secure our AI in the sense of, especially at the tactical edge, right? So in the predictive maintenance example, so if we're now embedding sensors on a UH-60 Blackhawk to help us do, make better, smarter decisions around when to send the aircraft into maintenance, well, that sensor needs to be protected. Right? So our network is not only on the DoD information network, but now our network is literally at the tactical edge across every device across the DoD, right? So how do we, just again, more from your thoughts, how do we at that level even protect, our algorithms that even at that level are using sensor data to help us make automated decisions?
A lot of it is, again, this is where I think automation is going to start helping us, is figure out, instead of manually putting all these sensors onto the network, having ways to, just like we do on the civilian side, come into our homes, be able to kind of access into the network and get on. Again, in the military right now, that's a much more painful process because it's much more strictly controlled. We'll need to find technologies to help us be able to get this Internet of Things to work on the battlefield in a little bit more robust way than we're doing today. Because today it's just, it's a very manual process to allow a new device onto either the enterprise network or the tactical network. Again, for endpoint encryption, we got to look at different, technologies, both to secure the data, as it gets passed across, as well as on the device itself.
So I know that you've been reading up on this adversarial learning thing. So for the audience, what are some things that they should know about adversarial machine learning?
So one of the things we didn't do a good enough job when we were kind of describing this talk is that we've overloaded the term adversary. So there's a part that we've been talking about here is that we have at the what I call the big A adversary, that people are trying to spoof your system, they're trying to get into your system. But there's also kind of the what I want to call adversarial network learning. There's a technique within neural networks to use generative adversarial networks to actually generate data. So typically the technique there is you'll have a generator and a discriminator, the two different networks you have. And then one of the networks is trying to trick the other network as it's developing, as it's training the other network. So it has its training data, and then it puts in the training data, and then it has a generator there that's generating kind of, again, just as an adversary would do, creating false data to go into the other network. And then they do a min-max, kind of a game theoretic just function that they're trying to do to minimize the value of one of the component or the competitors in that network, and then maximize the other one. So that technique works really well for areas where you're trying to, in the non-big A adversarial network. So you're trying to generate ways of coming up with new components. So I've seen ones where they're using it to model objects in 3D space. So you want to use a whole bunch of pictures of chairs, for example, and you say, well, how do we generate more chairs to make this more kind of a more interesting synthetic training environment or more interesting game environment, and then you don't have to have somebody hand generate every chair in your environment. It also works well in areas when you want to look at what's kind of the feasibility of human motion. So they'll take video snapshots of different people doing different moves, and then they want to translate that, again, kind of like you would do in a stop motion kind of motion picture into something that a computer can understand. And being able to maximize and minimize those functions works really well. But again, when you're throwing in true adversarial data and someone's trying to do spoof your DNS or whatever they're trying to do, it becomes a harder problem. And again, I've seen a number of contractors talk about some of their capabilities to find those type of attacks. And again, I think if the person developing their attack is again using what's called a stationary input, where your input is predictable, then yeah, you can get your AI to learn that really fast and defend against it. But if they're changing their input all the time and using different models all the time, you've got to be able to react to those and update your models really fast.
Yeah, thank you. So I want to talk a little bit about the DoD. So this is applicable to both cybersecurity and some of the applications you talked about before. In your framework that you presented in the slides, obviously we didn't talk about sort of the adversarial piece and making sure that in the AI development framework, if you will, how do you think that piece should fit in, right? So, like, where do we fit in the test environment, this whole adversarial learning component, and making sure that in the end, okay, we have our algorithms, but then our new systems that are doing reasoning and decision making are robust to those types of threats.
Right. No, so that's a great point. I think, again, since we're kind of in the infancy of deploying AI out to enterprise level systems, just like when the internet was kind of in its infancy, we didn't think about cybersecurity near at the level as we did. I think in AI now we have to realize that the data is spoofable. If people want to put bad data in, you've probably all seen images where there'll be a picture of a lion and it looks like a lion, but then somebody puts just small perturbations in that same picture, and when we see it, it still looks like a lion because we know what a lion looks like. But when the AI sees it, and now it's been overgeneralized for that one lion, and instead of seeing it's got certain data in there that it thinks it's a bunny rabbit or something. So that's definitely in the realm of issues right now with artificial intelligence. And we have to, actively spend time to figure out ways to keep it from being spoofed.
So I'd like to ask a question about the AI task force. One of the things you mentioned in sort of priorities is the whole the talent piece.
Sure.
So as the director of this organization, how do you what's the plan, if you will, for building out the AI talent? And AI, as you talked about, has many subfields. Between search and optimization, computer vision, natural language processing, what we call machine or deep learning. But how, as an Army enterprise, whether it be uniformed or civilian,
sure.
What are your thoughts?
Right. So right now, a lot of our AI experts are all coming from what's called an operational research background in the Army. So we have a series of what our functional area 49 is our kind of the personnel code on them. And they've all been just hand selected and managed at a very kind of rigorous level to pick the right team, get them to go to data science and get them into graduate school in the right area, and to mentor and coach them through their careers. Some of our other fields have taken the more traditional institutional path. So for our cyber warriors, Fort Gordon's kind of the Cyber Center of Excellence. We have a whole traditional kind of process that we're training our cyber experts there. So I'm probably looking at a little bit kind of as a hybrid model, both to look at getting it into the traditional institutions. So I know AI is going to become so widespread that everyone in the Army needs to know a little bit about AI, from the medical personnel to recruiting to personnel management to our warfighters. So part of it is getting it into every schoolhouse. But also it's going to be kind of to get that cadre of people and to maintain that. It's going to be a little bit like what the cyber warriors are doing, picking the right people, getting them to school, and then kind of creating a career path for them so we can keep them managed for a while, a lot like we do our operational research people as well.
So I would, at this point, like to open the floor for the next 15 minutes or so for any questions. And that could be related to our mini panel or to the AI task force.
Sir.
Thanks. And journalists are not the most numerate professions. I mean, I get the impression that what AI machine learning is, has the most near-term potential for is things where you have, as I said, clean data and lots of it, which means things like predictive maintenance, perhaps logistics, perhaps some personnel management functions, a lot of enterprise and support functions. But in terms of actually doing TPED imagery analysis and so forth, is harder, but it's dirty data, but there's a lot of it. But things like an AI strategist that would help you plan courses of action, or AI that's able to maneuver tactically and the optionally manned fighting field, for example. That sounds like that's a lot harder and a lot further out, because it's not only dirty data, but there's not a lot of the data, and the consequences for failure are, of course, very high.
Sure, no, it's a great question. So we'll take the robotics question first. So for the big initiative for manned-unmanned teaming in the military right now, especially in the Army, and I think we're looking at taking an incremental approach on that. A lot of our initial ones, the unmanned team won't be very smart, and it will be remotely piloted, just like a lot of the early drones were not particularly smart, and there was always a pilot in the loop flying the aircraft. So I think for a lot of our early manned drones on the ground will be exactly that. There'll be a soldier there, and they'll be driving around with a little control system. But again, we have large research projects. TARDEC is kind of the biggest one that's really pushing the ability to do that. But you're right, it's a little harder to do unmanned vehicles in a tactical environment, because you don't have the type of network structure that we'll have here in a city. It's hard enough if you look at the amount of effort we've been doing over the last couple decades to get driverless cars working in the cities, and we're finally there, but it's been, a concerted effort for nearly 20 years to make those work. But there are places that I think wouldn't be that hard. They're looking at leader-follower technology, where you'll have a driver in the front and then a set of cars or trucks following behind him. I think you could do the same thing with kind of some of the soldier mules, where the mule is smart enough just to follow where the soldier went. And so long as the soldier kind of knows his mobility or the mobility restrictions on that device, and he walks, doesn't climb upstairs and goes over locks or rocks, I think in the short term that's not that hard of a problem. From the standpoint of kind of battle management at the level, I think some areas are probably a little faster than others. I know a lot of our air defense systems probably already have some of those capabilities built into them, because the problem space is smaller. You're right, going in and invading a city where you have hundreds of insurgents or combatants on both sides becomes a lot harder problem. So I think we will grow with our technology from the more constrained problems to the harder problems. So one good area, just as you mentioned, logistics could be a good one. If we can get the right amount of ammunition pushed to the right soldiers faster, more efficiently on the battlefield, that's definitely a doable AI problem in the short term. No, it's not going to kind of do the whole art of warfare. But again, I think that's why this is a really exciting field to be in. So
the AI should not, basically, for your robotic systems, for your tactical systems, you rely very heavily on the human to make the decisions, and the AI just has to implement. Oh, that's the path to take.
Sure.
The human, the AI doesn't even know why the human avoided, going between the two narrow road underneath the hill, in a bad neighborhood, the wrong ethnic group. It just needs to know, I'm going to go down that road.
Right, exactly. And believe it or not, a lot of that technology, if you look at our air traffic control system, a lot of this is already being done, but at the same level of high-level automation for all our commercial aircraft. And the pilot's not building the route for their plane. He or she's being given the route from a smart system that's finding the ones, and they look at it as, yep, that's a safe route, and they accept it into their plane, and then they fly it. So I think in short term, that's definitely within the easy realm of feasibility. So.
I'll just add one thing. So, if in a scenario where you can think of, particularly if we're using AI for command and control assistance, if you will, I kind of think of an Alexa or an Echo, and the commander is able to ask Alexa, hey, what should I do? And in pretty much real time, help you as a commander or leader make a decision. If anyone's seen the show Legends of Tomorrow, and you have Gideon, basically helps develop courses of action, and people make decisions from it. I think that's, to train that type of model is not a short-term win. I would say that there are methods such as semi-supervised learning methods and deep reinforcement learning methods that can help with that. But in real time, that's going to require us either A, to have a lot of training data and have the computing power to be able to do that, which in a tactical environment we do not. Now we're working on that. We're working on mobile high-performance computing capabilities to bring to the battlefield. We're able to get those capabilities smaller and more mobile. Or we use a more active learning approach, but still requires a lot of scenarios to be able to learn from. So I think that's certainly, I think it's possible, but I don't think that's going to be a next 5 years thing, in my opinion.
Sean Drake with Stony Lonesome Group. Sir, the Army said that in order to succeed in this future battlefield, that they need to innovate at the speed of, or move at the speed of innovation rather than the speed of government. And you gave an excellent presentation today talking about the requirement side on AI, and we've had some other presentations on the cyber side. The big challenge seems to be sort of the valley of death on the procurement side. Where do the dollars come from to bridge that gap between the requirement side and the innovation side? And what is it that Futures Command is going to do to sort of make that a bridge rather than the valley of death?
Sure. No, it's a great question. And again, I think that's part of the way Futures Command is being organized. Right now, as you probably know, a lot of the kind of requirements pieces are done by TRADOC. A lot of our research and development labs are actually in AMC, which is kind of the tail end of our system. So I think Army Futures Command is going to be, just organizationally, we'll be able to bridge that a little bit better. We'll have the requirements piece, we'll have the science and technology, so the prototyping piece, all up in the front end, and then go into kind of the engineering development phases early, having that all in one organization. And then once it starts transitioning into program of record, then that's probably when it get transitioned over to AMC. And I think that's much closer to a lot of what largely the same model that the larger defense firms kind of model their own internal acquisition and development kind of cycles. But you're right, there's a big push both in the House, in the Congress, and within Army leadership. How do we make this go faster and smarter? That's one of the big kind of charters of the Joint AI Centers. How can we do this kind of at an enterprise level? I know the Defense Integration Unit also has kind of that same charter. So hopefully between the big teams of us, we can make the DoD a little bit faster and more agile than it's been in its history.
Hi, Tiffany Easter from Texas A&M. I'm a student. Within AI, Cyber, and Futures Command, does the Defense Innovation Unit play a role in that at all?
So we are definitely working with the Defense Innovation Unit. I mean, I just spoke with some right before this talk. So we hope to leverage what they're doing. Right now, at least my task force is not trying to move money around or stop any projects. It's really doing kind of same kind of piece that the Defense Innovation Unit is, finding those right projects, and then again taking those projects out of kind of the laboratory or at kind of the startup level, and then how do we expand them and grow them to become the big projects, is kind of what I see, at least for the AI piece for my organization, and then for broader kind of aspects, the rest of Army Futures Command.
Hi, Patrick Muldray, threat intelligence analyst from a small startup called CyberCube. We provide cyber risk analytic product. I'm curious. I appreciated the overview of the types of attacks against AI systems that were provided in the beginning. I'm wondering if you've actually seen threat actors in the wild conduct any of these, or is this limited right now to academic research and sort of labs and so on? Is it theoretical, or is it already happening at the moment? And if not, do you anticipate it in the next couple of years from our adversaries? And also, finally, do you anticipate AI threat actors themselves?
So I would say, from my perspective, I'm not working in operational cyber right now, so mine's purely research. But the whole AI hacking and attacking other AI, which kind of is your last point, I definitely see that happening. I mean, with bots and all other types of autonomous type things that are really AI in themselves, I think that's already happening. But yeah, most of my work in terms of adversarial learning is in the space for more of a research type lab scenario. So there might be someone here from Army Cyber or Cyber Command that can speak to that, but I can't.
Good afternoon, sir. Major Stevens from US CENTCOM. One of the problem sets that we have is counter-propaganda in the, we call it web ops, but
Sure.
Our own message. What authorities do you see with, or what authorities do you see would be needed for us to employ adversarial learning against commercial social media in order to suppress their message and promote our message?
Sure. Well, I mean, from learning, I don't think we need any authorities. I mean, I think we can, I mean, the internet's free, and if we want to watch what everyone's doing on open source capabilities, I don't think that's definitely outside the scope of our Title X authorities. When it comes to more offensive informational operations, I actually don't know what our authorities are, so perhaps one of the later ones can do it. But it is, as you know, I mean, from a lot of the books that are coming out, social media is one of the new battle spaces. And then how we as kind of Title X forces are going to be able to maneuver that is of great questions. And I think the last talk talked a little bit about that as well, on kind of what can we do and what can't we do as our country, given what it does, and especially what can we do as Title X forces. We're in a brave new world. So, well,
Any other questions?
please.
I'll keep asking. One of the things that you mentioned just in passing is, we tend to sort of equate, AI, we know what AI is, that's machine learning, but there are these other things.
There's lots of other types of AI.
Supervised and Bayesian, which I know the buzzwords, but I have no idea what any of them mean. So for those of us who are slower students, perhaps, could you look to what are some of the alternatives for the classic machine learning that's so dominant in this space that might, for a military application, for these dirty data sets, these smaller data sets, might actually have some advantages over the straightforward ML.
Sure. So this is a rumor. So I mean it's so old it's almost comical. But when I was getting my PhD, one of my office mates was a big Prolog learner, and Prolog was an early AI language to do symbolic reasoning. So it's kind of a fancy version of an expert system. So from the 80s and 90s, you may have heard about all these rule-based systems that we had. A lot of those systems, we don't call them quite expert systems now. We just call them business processes, because a lot of them work very well. If you think a lot of the forms you fill out on the web, they're all these connected together, and there's logical dependencies between them. There are some languages like Prolog that do that really well. And I had heard a rumor, and again, this was from the mid-90s, that most of the programmers and the Prolog programmers in the world were in some secret room in the basement of the Pentagon, maintaining kind of the interactions of some of the war plans. So you can imagine that there's these kind of dependencies in there. I don't think that, I have not found that room yet, so I don't think it exists. But you could well imagine that you can use Prolog type systems, other expert systems, other symbolic systems, where you're actually reasoning about entities in our real world and coming up with those logics. Like, I mean, a good example is like Matt is a male. So you can make inferences upon that type of statement. You can encode that statement into a logical framework, and then you can make inferences upon that. And that's kind of the antithesis to kind of the neural connections that you have with a lot of the machine learning neural networks, is that symbolic approach. I think a big area of research going forward is how do we combine those kind of the traditional symbolic approaches with typical neural approaches to actually get some of that kind of coded understanding of the reality, the semantic understanding of the world, as well as kind of this, how do you react quickly to the data you have with your neural solution. You want to talk a little bit about hybrid solutions?
Yeah, so artificial intelligence in the end really comes down to a machine being able to perceive, reason, and help make decisions. So there's different types of problems within that space. You have the, given X, tell me Y. So that's typically where machine learning is. You have a supervised learning where we know the label, like I know the images of cats, so I can build a model that predicts, given a new image, that it's a cat or not, or a cat or a dog. So that's one type of machine learning. You have another type of machine learning known as unsupervised learning, and that's where we don't have labels. We don't know, and typically the learning problem is to find basically homogeneous subgroups in the data, okay, or reducing the number of dimensions. So, for example, I was doing an AI challenge a couple weeks ago, and we're dealing with a data set with over 100,000 columns, 100,000 features. Well, to have the computing power to be able to learn from that many, think of columns in a spreadsheet, that's a hard problem. And so unsupervised learning techniques allow us to reduce those dimensions. So that's one machine learning. You have deep learning. Machine learning, we typically do what's known as feature engineering. Given the inputs, we want to change the features in a way that helps us learn better at the deeper levels. So for example, let's say I'm trying to predict household or maybe rental prices in a particular location, and one of our features is maybe median income. Well, I could use median income as a particular feature, or I could break that into bins, and I could say, $0 to $20,000 a year, $20,000 to $40,000. Right now I have bins, and so that's one very simple or trivial example of feature engineering. So in machine learning, we'd have to do a lot of manual feature engineering for every single data set, and we typically develop what we call pipelines to do that. Deep learning kind of throws it out the window, and it says, hey, there's some sort of latent pattern or structure that as humans we can't even learn. So let's let the algorithm kind of learn for us, and that's what deep learning is all about. And depending on the type of problem, you have different types of deep learning algorithms. So if you're looking at sort of image data, well, you use there's structure in images, like pixels, that allow us to use what we call convolutional neural networks. Or if we're dealing with time series data or trying to translate text, from Chinese to English, whatever, there's techniques for that. Then you have the whole making decisions over time. So for example, that's really where the heart of AI is. It's really, okay, maybe I've detected a threat and I've characterized it, but then what does an analyst do? And then how do we learn from that? And we typically call that reinforcement learning, or in the operations research world, Markov decision processes. You have computer vision, you have biologically inspired algorithms. So AI is really a really broad
field.
That's why when people say AI, ML, they're not the same thing. ML is a component of AI. So I think we're out of time.
And again, I want to thank everyone for being flexible with us. I was very happy to give my stump speech to you all, so hope you enjoyed it. I will be around afterwards if you want to have any more questions.
Thank you for coming, sir, for fighting the weather, and here's a box of chocolates from the Army Cyber Institute, thanking you for being